Just like every image is made up of pixels, every body of text is made up of smaller constituents. You could let those be words or characters, but we typically use words as the meaningful unit rather than characters. And that's because characters don't really have much meaning outside of the word that they make up. For most problems of interest, the same letter doesn't mean the same thing when represented in a different word. So the first step in processing text is to break down the text into those discrete, meaningful units, which we call tokens. And they're typically words. And we call the process of doing that tokenization. So tokenization is the process of breaking up text into its constituent parts, which each have a semantic meaning. And to perform tokenization, you would want to do things like split the text on spaces, normalize all of your capitalization so that a capitalized word is treated the same as its lowercase counterpart, remove spelling mistakes, remove special characters like semicolons and such, and much more. There's many different things that you could add to improve your tokenizer and make it more advanced. So I'm sure that you could implement that in Python pretty easily, but to save yourself time, you can also just use one of the many standard tokenizers which someone else has put online and made available to you. And there are many different publicly available tokenizers. As an example, the most basic is called the Basic English Tokenizer. It does a few things. So it tokenizes the text. It then adds a space before and after, commas, single quotes, periods, parentheses, exclamation marks, and question marks, so that each of those will eventually appear as their own token. Then it replaces semicolons or colons with a white space so that they won't be included as tokens because they aren't really as meaningful as the other punctuation that we listed. And then it removes double quotes, and then it splits all of that on a white space. So you end up with a body of text which is then converted to a set of lowercase words which each have a set of lowercase words with meaning as well as the meaningful punctuation which that body of text contains. So that's an example of a tokenizer, the Basic English Tokenizer. But like I said, and as the name implies, this tokenizer is very basic. So I'm sure you can think of cases where these rules break down and they won't give you exactly what you are after. One example would be where the letters of an acronym like AI are separated by a period, and the Basic English Tokenizer would treat the A, the dot, and the I as different tokens. And because of that, because of the reason that this tokenizer isn't great and it has those kind of problems, there are much more advanced tokenizers that can handle those kind of cases as well, which for the moment I will leave you to look into. So how do we use those tokenizers? Well, many libraries have built-in functionality to get access to them. And so I'll show you how to do that in TorchText. In TorchText, you can simply import the getTokenizer method from torchtext.data.utils. And you can then create a tokenizer by calling that function. And specifying the name of the tokenizer which you want to use. You can check out the TorchText docs for exactly how to do that. And I'll use the Basic English Tokenizer to start with, which unlike others, you won't need to go and install from elsewhere. So Basic English Tokenizer is already available. So once you've created that tokenizer, you can then call it on a body of text to get the tokens as a list. So I've got that text up here, and I'm going to call the tokenizer on it to get all the tokens which are in that entire body of text. So if I run that, you'll see that this is the output. Here are all of the tokens which make up that piece of text. You can see that using the Basic English Tokenizer, it's done the things which I mentioned. It's lowercased everything, it's removed some of the punctuation, it's separated out some of the punctuation into its own token, and the other stuff that I mentioned. One other thing that's important to notice here is that because some words appear multiple times in the same text, they appear multiple times after they've been tokenized. The tokenization gives you kind of a mapping between every token which should be in the text and that token in a list. It doesn't just give you the unique instances of the tokens in there. And it's as simple as that, really. Tokenizers convert text into individual tokens which represent the meaningful constituents of your text.